list, I didn't have to round it in. Okay, maybe. So what does this tell me to do right here? I take the data point times the weight. So what column am I going to make right here? The data point times the weight. So it's going to be the data point times the weight. Isn't that exactly what we're doing right here? 30% times 5 plus 20% times 6. So which data value contributes to the mean the most? Seven. Yes? 7 contributes to the mean the most. And then 5 is the next most and so forth, right? And poor little 8 doesn't contribute much at all. So that's why we do the weight times the data value. So I get here 1.5, 1.2, 2.8, and 0.8. So now we know the formula for the mean when they give me an x p of x table, this probability distribution. We know what it is. How did I get 6.3? What did I add up? The sum of xp of x. So there's our first formula that we're actually going to use for real, not this stuff. This was why that works. That's the thing in operation. So our formula for the mean is sum of xp of x. Bam! So if I was gonna roll a die, and I would give you money, the closer your guess was to what it showed up. What's the best number to bet on? 7. Neat. If I was gonna roll one normal 6-sided die, I'm with you though. I'm with you. If it was 2, and 7's right answer. If I rolled one die, what's the best number to bet on if I'm gonna give you money based on how far away you are from what actually happens? If I roll a die, if I roll a die many times, what do you expect the average to be? All right, maybe this is too much. If I roll a die, I could get a 1. And if I roll it again, I could get a 6, right? Is it going to show up more up towards 6 or more down towards 1? If I roll it a lot, it should be equal amounts. So if I roll a die many times, what should the average be? 3. Does that make sense? I like it. Isn't that the amount that I expect to happen? That's my best guess for what's going to happen. So here's what's really cool. You'll see this. Another name for mean is expected value. It's the expected value. It's how much I expect to happen. Okay, I like it. And what's really, really cool about that, and maybe I oversold it, but I don't care. This is still kind of cool. What are the first 3 letters in the formula for mean? EXP, right? So the mean is also known as the expected value. That's kind of nifty. Did we do that on purpose? No, it just sort of happened. Okay, I like it. And you're all like, that's just for you, math boy. All right, it's just mine. I don't care. I still like it. All right, so what do we say? So we got the mean now. What was the other thing we had to calculate? Spread, standard deviation. I like it. By the way, real quick, before I go into that, I want to show you something kind of cool. What was the formula for the mean before? What was the formula for it? What is it in English? Add them all up. Divided by?
EX divided by N.
Yeah. Sum them all up, add them all up, divided by how many there? What's the main thing that's sort of missing from this formula then? The over n. Stay with me now, come on. What is on the bottom of a probability? What's built into the bottom? What's always on the bottom of a probability? The total number of things that could happen, also known as n. So these are the same formula. Because what's on the bottom of this dude? Freaking n. That's another thing that's cool, and it's got to be for you too, because that's just too awesome. All right. And you're all like, you lost me at good morning, Jeff, so just keep going. All right, shit. That's sort of cool. You got to admit, that's a little tiny bit cool. I mean, it's the same formula because P of X has n on the bottom. So it does have n. It just doesn't show up because it's a part of this dude. But they're the same stupid formula. All right. Moving on. So how do I get, yes?
Well, is there a reason that we use this new formula? Like, does it work better?
You ready? You ready? All right. I was trying to figure out which way to go with this. I still want to work with those a little bit more because they're going to be a little bit easier to work with to develop because we still got to make the formula for standard deviation. Well, let me give you a grosser table. Because what could I do with this? If I gave you this table, couldn't I just write 3 5s and 2 6s and 4 7s and just do it the old way, Jeff? Screw your new way, math boy, right? Sorry. So, here's an example problem that tears that to shit. So what if I add this? Not even because the x's are gross. Here, the x's are not gross. There's only 4 of them, right? So how horrible could it be? Oh, I gotta be careful now, shit. Way to go, Jeff. What do you want from me, Jeff? Let's do this. What am I trying to be careful about?
Making it not go over 1.
You guys can check me. See how good I was at doing that. Real quick. Make sure that's supposed to add up to be 1. Or close to it. Maybe these were rounded, right? Look at me trying to cover my ass. Adds up to 1? Yay! All right. Now, real quick. Come on, you guys can do this. Dude, does everybody understand what I mean by, if I gave you this table, couldn't you just write 3 5s and 2 6s, right? Well, how many 9s would I need? 3,171 9s, 5,239 10s. If you do it that way, I'm not going to look at that. All right? Turn your paper this way and just start writing 9, 9, 9, 9, 9, 9, 9, 9. Screw Jeff and his new way. 9, 9, 9. This is going to work. No? Yes? Maybe? So that's what I said earlier. We started with a small list, so it was easier to handle, so we could see where the formula came from. And now we can handle things like this. Because maybe they talked to 12,000 people. So there were 3,000 something 9s, right? But how would I figure out the mean? I would just make the xp of x column. And you can admit that's a hell of a lot quicker than making a list of 3,171, blah, blah. You guys with me a little bit? Not really at all? Whatever you say, Jeff. Real quick, since I got this up here, let's figure out what the mean is. Somebody help me out. So this is going to just be multiplying x times p of x. And you can start to see how you could do L1, L2, and L3 would be L1 times L2. Do you see that? If you want to. If I give you a long-ass list of these, you might want to do it that way. What you got for this first one? 2.85. Oh, 2.8. 8539. And then this one's easy. 5.239. And then this will be 8 point, I don't know. What is it?
0.8.
Oh yeah, 0.8, thank you. 0.8371. And then this one is 0.98 something, maybe? 994. Thank you. And then how do you get the mean? Just add those up. You guys with me? So yes, we created the process off of a simple list of data, just so it was quick and easy to kind of compare the old way with the new way. And now that we created a process, it doesn't matter how gross these get. I can just do this. I mean, that's quick. You gotta admit, that's beautiful. That kicks a lot of ass. Okay, maybe. So whatever the shit that is, what is that, 7, 8, 9, almost 10? 10 point something maybe?
9.9.
All right, 9, blah, blah, blah. Okay, all right. Is that cool? So we do that in a lot of math. We develop a process using a simple situation so we can use old ways of thinking about it and see new ways, and then the new way can handle something worse. That's how some mathematics works. Well, hell, that always freaks me out. So, if I find the mean, not by summing up x and dividing by, but by multiplying x by p of x. Stay with me now. What was the old way to figure out standard deviation? I'll get it started. Maybe I'll keep going a little bit. You guys are all like, I've blocked that out. Yes? Oh, we got somebody with the notes. I like it. That's a smart idea.
What is the line over x?
Oh, we're going to do population. That's all right. X minus mu.
Square.
Remember we had to square it because there were stupid negative ones? You remember doing that? Yeah, like, I don't remember what I had for breakfast. All right. Neither do I. That's the old way we did it, right? This would be so cool if you could see this. So do you see how I don't sum up x and divide by n, I sum up x times p of x because it has n in it, like I just said earlier. So now I don't sum these up and divide by n, I take these and multiply by p of x. All right, now, we're actually not going to do that. But that's the way, right? Let me write what the new formula would look like. It would look like this. Let me do the variance just because I don't have to do the square root shit. I'm not used to writing it this way. Let's see. All right, so that's what that would be. Perfectly valid way. But can you see how much shit I've got to calculate to get there? I don't know if you guys could see that. I mean, I have to calculate what x minus mean is, and then square it, and then multiply that by p of x. It'd be multiple columns, possibly, right? But go with me. Here we go. This is what I call the conceptual formula, because what does standard deviation tell you? This is the problem that we so loved that Jeff asked on the first test. Because some people got really close when I said, what does standard deviation tell you in general? It doesn't just tell me how far away the data is from the mean. If you just added 2 words, on average, yeah. The average distance from the data points to the mean. You like it? So what should show up in anything that's related to a standard deviation is this distance from the data points to the mean, right? Do you guys see that? Yeah, because it's right there. So I'll just answer that for you. There it is. Later this semester, we're going to see something that's like a 2-dimensional standard deviation. And there's going to be a x minus the mean and a y minus the mean, and we'll see that, and it'll be neat. But that's later. Don't worry about it yet. So anytime I have something that's supposed to be like a spread of data, I have to find this somewhere in it. So this is what I call the conceptual formula. It's not the one we're going to use. There's a much easier form of this to use. What I need help from you guys who have gone through algebra, and you know algebra, if you just looked at this piece in algebra class, what is it crying out to you to be done? Can't square, it's just sitting there. So it's not an equation. I can't square root it because I don't have another side to balance doing that. If I said, what's 9, you can't say 3 because it square rooted it. No, it's just freaking 9. I can't do shit to it unless it's an equation. What would I do with something like this in algebra?
Don't you have to like make another like equal it to it?
There's no equation here. So in algebra, if you saw this, what would you do to simplify it? Write it twice and then FOIL, right? Real quick, just to make you hate me more than you currently do, I wish to God we never taught FOIL. FOIL is stupid shit. Here's why. Did anybody remember FOIL? Do you guys remember FOIL? Yeah. So if I do this problem here, write it twice. Why do I need a mnemonic device? You guys know mnemonic device, right? Like if anybody's in music, you got Every Good Boy Does Fine or something like that. Is that right? And Face. No? Anybody in music know what I'm talking about? You guys like, dude, whatever subject you talk about, I have no idea. All right, shit. Anyway. So please excuse my dear Aunt Sally, PEMDAS. That's a mnemonic device, right? Which is useful because it's hard to remember the order because it doesn't make intuitive sense. Why do I not need, FOIL means first, outer, it's bullshit. If I just had this, I would distribute, right? If it was just 5, I just distribute the 5. So here I just got 2 things to distribute. I don't need freaking FOIL. I distribute the y. What's y times y? Just y times 5. And then the 5 gets turned. I don't need FOIL. If I add one more term to this shit, what's it going to be? No? Okay. So what's 5? And then 25. Are you guys with me? So what I was saying, in the course y squared plus 10y plus 20, blah, 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 blah. Okay, right? Normally that's kind of bread and butter. That's some algebra that doesn't scare people as much. It's when I factor that shit that people freak out. We're not going to factor. But real quick, if I had this, FOIL won't do shit for me, right? Because now I have a middle term. That's what I meant by it would have to be first, first middle, first last, last first, last middle. It'd be no? I'll stop. I'm sorry. Hopefully some of you guys see what I'm saying. Anyway. So FOIL is bullshit. So just take a minute and do this for me. Just so I'll shut up. Just do that for me. Multiply that out. I'll leave that for a second. Just multiply that x minus mu squared. So what do you guys get? X squared? 2 mu x plus mu squared. All right, so let me write this again. This is going to be, is everybody cool with that? That's what you get when you FOIL it. Or you just multiply the shit. That's what you get, right? Let me rewrite this a little bit. Again, right now, I'm in the middle of a derivation of a formula we're going to use. You're never going to have to do what I'm doing right now yourself. We're going to get to the end, and that's where you have to really, you worry about it, but right now, hopefully, you can follow. Now, you still have your algebra hat on, whatever. I hate saying that kind of thing. Thinking algebraically. There we go. What would be the next thing you'd want to do with this? Don't worry about this guy. You could do it. Yeah, the p of x is going to go through, right? So what would be the first term you would get? Yes. All right. Now. If any of you feel gypped by what I'm about to say, you can come to my office. I'll show you the steps, but I'm not going to put you through summation algebra. What's really neat is all the rest of this shit, all of it, if you work with it, it becomes this, minus the mean squared. Is it obvious? Oh, hell no. Right? I love you guys so much. I want you to at least see where that came from. Everybody see where that came from? That's the x squared p of x. The rest of this stuff, if you work with it and get like terms together, you will get here. All right. And again, this is not summation algebra class. This is statistics. So right here, so these two formulas are the same. This one, I am claiming that one's easier to use. You all know I'm insane. So you're like, I'm not sure about that, Jeff. You're insane. But watch. How many columns? I don't need all this shit now. Get away from your shit. I just need one more column, because what column do I need? How do you tell? I told you way earlier. Whenever you hit a formula, it's got a big E in it. Cover it. What do I need? I need a bunch of these. Right? I've already got x p of x, so I just need x squared p of x. What I do, because I'm weird and insane, is I do this one times this one. What's x times x p of x? What is x times x p of x? X squared p of x. So 5 times 1.5. Who is it? 6 times 1.2. 7 times 2.8. So 19.6. Is that what that is? I had somebody help me and then they went away. And then 8 times 0.8. Yeah, it's 19.6, okay. I love you guys. So if I give you x and p of x, I have to give you both. Because you have to know what percentage of this and what percentage of this. Then you make this column to figure out what the mean is. And you make this column to plug in what you need to figure out what the variance is. So what do you get when you add these up? Let's see, 26, 40.7. You with calculators can check my brain. It's early. I did have caffeine though, so I feel pretty good. 40.7? Right. And now I can plug that shit in to figure out what the variance is. This is what? 40.7. We just figured it out. Right? That's 40.7. What was the mean? 6.3. And the most common mistake people make is they forget to square that poor dude. Poor little dude. Square it. So help me out. What do you get for the variance? What is it? 1.01? Is that what you guys got? Anybody else? Yeah. That's all. Holy shit. And then what's the standard deviation? That's awesome. It's almost exactly 1, so it's going to be like, I don't know, 1.006? I don't know. 1.0050? 005? Like that? Okay. Woo! I have for you, excitement, excitement. One side of this is a completely worked out problem with all the same questions worked out that I ask you on this problem on the back. So if you're stuck here, you can always ask me, or you can always just see what I did over there. All right. These are the kind of questions I enjoy asking you in a quiz or a test. So I want you to work on that blank side. If you need to borrow a calculator, give me a minute. Get back up there before you come up. Anybody need a calculator? Come up, y'all. Turn this dude off.